Which one is that?
Secant squared x plus cosecant squared x equals secant squared x times cosecant squared x.
All right, now you should honestly question that because you get just saying that if I add two things together and then I multiply the same two things together, I get the same answer. That doesn't really make sense, but let's see if we can prove it, whether that's true for this. Now, I put these over here on the board. Sine squared plus cosine squared equals 1. Sine squared equals 1 minus cosine squared. Cosine squared equals 1 minus sine squared. Those probably get used more than any other. Okay, just so that they're there in front of you. Okay, you're not going to use them on all of them, but like I said, they get used probably more than any other identity. All right, right now I can't really do anything. What did we say you have to do before you give up? Convert two sines and cosines. You got to do that. So this is 1 over cosine squared plus 1 over sine squared equals 1 over cosine squared times 1 over sine squared. All right, now, when you're multiplying on that right-hand side, so 1 over cosine squared times 1 over sine squared just can become 1 over cosine squared x times sine squared x. I can't really do anything else with that. Okay, at least at this point. So just leave that. So let's work on the left-hand side. Well, do the math. How do you add those together? If it says plus, we got to add them together. You got to get a common what?
Denominator.
A common denominator. Well, it's going to be cosine squared times sine squared. So this one has a cosine squared. We need to throw a sine squared in there. So sine squared x times sine squared x plus 1 over sine squared. And then we got to multiply that one by cosine squared x. All right, so they're going to have the same denominator. So I can just write this as sine squared plus cosine squared over the same denominator, which is cosine squared times sine squared. And we're done because what's sine squared plus cosine squared equal? 1. So right here, this numerator equals 1. So it's 1 over cosine squared times sine squared. Got it? So they're not, most of them were similar to the notes. But there's going to be some that are not, you're going to have to rely on just going through the steps and see if you can figure them out that way at times. All right, any other questions on the homework that just kind of got stuck on, weren't quite sure, thought you had it? Jay?
32.
32. All right, let's see here. What's the original?
Cosine of x times cotangent of x plus sine of x equals cosecant of x.
All right, what'd you do first?
I converted into sines and cosines.
So tell me what you wrote, just to make sure you didn't make a mistake there.
Cosine of x times cosine of x over sine of x plus sine of x equals 1 over sine of x.
Okay. What'd you do then?
Then I times in the cosine to the fraction, and then I got cosine squared of x over sine of x.
Okay, just hold on. So far everything is good.
I guess
Do the math. You got to
Common denominator.
common denominator. So think about that sine of x over 1. So now make sure to add it. That means I need to add a sine of x here and a sine of x there to get that common denominator. So now what I got is cosine squared x. I'm going to take an extra step here. That's going to give me sine squared x over sine of x. This should just be sine of x over here. There we go. Is that right there? Okay. So now you get that common denominator. So I say that a lot. I just say do the math. It means you need to multiply, or you need to add, or you need to subtract based upon the problem. So somehow I got to add those together. I do get a common denominator. And you're going to get cosine squared plus sine squared, which equals 1. So I get cosine squared of x plus sine squared of x over sine of x. And we said that will equal 1. So I get 1 over sine of x, which you had over there. All right, good. I do see a lot of improper canceling. I don't know if I mentioned this yesterday. I can't remember. But if you have something like cosine of x plus 2 over cosine of x, can I cancel those cosine, and cosine? Okay. You cannot. Okay, if you have a part of an expression, something's being added or subtracted, you cannot cancel that. You can only cancel things that are being multiplied. So if I have cosine of x times, say, sine of x plus 2 over cosine of x, now those can be canceled because that cosine is out front multiplying. Just be careful. And like I said, and you could not cancel that sine of x with anything, like if another sine of x appears. So just be careful. I see a lot of improper canceling. It's hard to describe because it doesn't come up all the time, but be careful there. All right, get out your little half sheet of paper, your identities. We're going to go over a couple other, there's a lot of different ways to do these. We're going to go over a couple more together. And conjugates. Let me just kind of remind you what conjugates are, because it says number 5 on that little half sheet of paper. It says use conjugates, and those are going to come up at times. So when you're stuck, you got to use them. But you're like, I don't know what a conjugate is, so how do I use it? So let me make sure you know what a conjugate is. Would these go back to complex numbers? We use them. So 3 plus 4i. Does anybody remember what the conjugate is to 3 plus 4i from complex numbers? Jane, you remember? Robert remembers. He says, no, I don't. Sydney?
3 minus 4i?
Yeah, you just make it 3 minus 4i. That's the conjugate. We did those when we rationalized denominators. Like if I had 2 plus the square root of 3, what's the conjugate of that? 2 minus square root of 3. So those are conjugates. Now in trig, if you got 1 plus the sine of x, its conjugate is 1 minus sine of x. Okay? Just basically it's a binomial. One's positive, one is negative. That's all you got to do, conjugates. If I got sine of x plus tangent of x, its conjugate is sine of x minus tangent of x. Okay. So make sure you know what conjugates are in order to use them. All right, copy that down. All right, now I'm kind of giving you a clue because it says solve identities using conjugates. Those will come up to play here in a minute. All right, on that left-hand side, okay, there's really nothing you can do. You can't split it apart. Remember, you can't split it apart if it's 2 pieces on the denominator. On the right-hand side, let's at least explore converting to sines and cosines and see where that goes. So secant of x is 1 over cosine of x minus tangent of x, which is sine of x over cosine of x. So they happen to have the same denominator, which is nice. So I can rewrite that as 1 minus sine of x over cosine of x. 1 minus sine of x over. All right, but now I'm kind of stuck. Now, does that match up with the left-hand side? No, not the same. So if I take a look at number 5 on my little sheet, I've converted the sines and cosines. I've stayed focused on the answer because you guys were really focused. I could tell. We worked on both sides. Now, use conjugates. In expressions containing 1 plus sine of x, 1 minus sine of x, so on, it is often helpful to multiply both the numerator and the denominator by the appropriate conjugate, and then use one of the forms of the Pythagorean identities. Well, we'll explain that in a second. Actually, you got two options. You got a 1 plus sine of x here, and you got a 1 minus sine of x. I would work with the denominator first. As with everything, doesn't guarantee that's always going to work. It just is going to be helpful more often than not. So what is the conjugate of that denominator? It is 1 minus sine of x. So just on the left side, we got cosine of x over 1 plus sine of x. You're going to multiply the top and the bottom by 1 minus sine of x. Okay. As long as you do that, you're not changing the value of that fraction. Okay, we're just going to give it a different form. Now, I know that I'm not going to distribute that cosine x yet. Save it on the outside, see what happens first before you distribute it. That's going to be a common thing. Because I see over here, I got a 1 minus sine of x. I got this. I don't want to mess it up. So I'm just going to leave that as cosine of x over 1 minus sine of x. All right. Well, I clearly don't have a bunch of 1 and so FOIL those together. Okay. FOIL those together. What is 1 plus sine of x times 1 minus sine of x? That's going to be different. Going to give me 1 minus sine squared x. All right, so just stop there. See if you can figure out where we're going. Whitney, you know where we're going?
Does the bottom part equal cosine squared x?
1 minus sine squared does equal cosine squared. Okay. Now, is that going to be useful here? Yeah, because you got this cosine here, and it's eventually going to cancel. So I got cosine of x over 1 minus sine of x. Now, this is the main reason we multiply by the conjugate is you get something squared, like 1 minus squared. You typically one of those Pythagorean identities we can replace. 1 minus sine of squared is cosine squared. Well, all right, I basically now all I got to do is cancel here. I get 1 minus sine of x over cosine of x. And we match up, right? There we go. So multiply by the conjugate. You're kind of at a spot. I'm stuck. Okay, once I got to here, and then I got this. Now, if I multiply by 1 plus, I think we would have gotten there in a different way, but we still could have gotten there. I like to take care of the denominator first. So that's how you do a conjugate. All right, something else that comes up, factoring. Okay, comes up in different types of factors. So copy that one down if you would. All right, Nick, you see what factors? Not yet? Okay, all right, let me give you a hint.
Would it be the cosine of x and the minus sine x on the left side?
Those two will factor. Do you know what into?
No.
No, all right, let me kind of break it down. All right, just pay attention. What's x squared minus y squared? Remember what that factors into? That factors into x minus y times x plus y. So if I make it x to the fourth minus y to the fourth, that's going to factor into x squared minus y squared times x squared plus y squared. So that's basically the difference of squares. So now instead of x fourth minus y to the fourth, I got cosine to the fourth x minus sine to the fourth x. So that's going to factor into cosine squared x minus sine squared x times, and I'm about to move it over. Oops. Times cosine squared x plus sine squared x. All right, Alyssa, what's cosine squared plus sine squared equal? 1. Yep. So that equals 1. Okay. And so that leaves me cosine squared x minus sine squared x. All right, Chris, you know where we're heading?
No.
No? All right, I'll give you a second to look. Put a little pressure on it. I can see you squirm a little bit.
Definitely moves, like, I don't know.
You're not sure? All right, what do we got on the right-hand side? What don't we have on the right-hand side that we got on the left-hand side? Cosine. How can we get rid of a cosine squared?
Good question. 1 minus sine squared.
1 minus sine squared. So cosine squared. There's no cosine squared over here, so I got to get rid of that. So that is equal to 1 minus sine squared minus sine squared. Okay. So now you got this subtracting the same two things. That gives me 1 minus 2 sine squared x. Okay, for that one. All right. All right, so we're good. We got left-hand side equal to the right-hand side. So it is an identity. Okay, it is an identity. All right, you're still factoring. Now, this isn't an identity, but this will come up in some. And like I said, I just want to at least hit this. All right, look at that. Copy that down. Think, what does that factor into? See if you can figure it out. Go over here in a second. But copy that down. It's not an identity. It's just saying factor that little trinomial. Go into there. I think this is a trinomial. That was kind of a hint. You have a squared term, you have a linear term, you have a constant. Think of that as x squared plus 3x plus 2. That would be like the equivalent form. Well, factor x squared plus 3x plus 2. That factors into x plus 2 times x plus 1. Remember, you just want two numbers that multiply to 2, add to 3. All right, so if you see something like this, you see a trinomial, you see three terms. The first term is squared, or you can rearrange them. The second term has just the cosine. The third term is a constant. You want to try to factor it. So that will factor into cosine of theta plus 2 times cosine of theta plus 1. Okay. So I just need you to recognize that something like that will break down. Reason we like to factor, when things are factored, they can cancel. Okay, and we can get rid of them. All right. Now, like you said, that's not an identity, though something like that will come up in certain times, just be able to handle it. All right, I want to take a look at one more and then give you some time in class to work. That way I can give you a hand if you need it. All right, copy down that one. And I do always say you have to convert the sines and cosines before giving up, but that doesn't mean you always do that. One of the things you should try to do is say, can something factor right off the bat? Now, the left-hand side does factor, it just has a GCF. Okay, you don't look too far into it. What I mean by that is, if I had x to the fourth plus x squared, I could factor out an x squared and it would become x squared plus 1. Well, that's essentially what we got right there. Except it's not an x, it's a cotangent of x. So what can I factor out of those two? I can factor out a cotangent squared x. Parentheses. Now it gives me a cotangent squared x plus 1. All right, you compare your left side to your right side. Well, they're not exactly the same, no, but at least what piece do we have? We have the cotangent squared. Right now, what I'm doing is I'm crossing my fingers and I'm doing what Mackenzie's doing. I'm looking at my identity sheet and hoping that cotangent squared x plus 1 equals something. What does it equal? It equals cosecant squared. So I'm going to put a little note to myself just because that one isn't, one that I always remember off the top of my head. I might have to look that one up. Cotangent squared x plus 1 is equal to cosecant squared x. So now that just becomes, all right, we'll go purple. Cotangent squared x times cosecant squared x, and we're done. Okay, so sometimes you just got to say, all right, does anything factor? And then kind of go from there. And anytime I see something squared with a 1, or really two things squared, I'm looking identity. I'm thinking identity. Okay. And so we look at our identity. She said, yeah, okay, that's cosecant squared. All right. None of them are all the same. You got to make sure you remember that. You just got to learn some of the rules, go through the identities. I want to give you time in class because if you get stuck, I want to be able to help you, or you can help each other. See how far you can get here. You should get at least, I'm telling you, 3 of them done. Or, don't, if you're stuck, put a hand up, let me help you. It's usually a quick fix. All right, I'm going to post this here while you're getting started.